Welcome to another data recovery video. This time I'm working on a Seagate external hard drive that's been brought in from Brisbane. Now the customer reports it has stopped working. They're the ones that have removed it from this enclosure, and the model number is a Seagate Barracuda 7200.12 1 terabyte. These are an older hard drive. You don't really see them come in that often. It was manufactured in 2011, and when you turn it on, you get a quick signal on the 5-volt line, but there's completely no signal at all on the 12-volt line. So let's take the PCB off and have a look. And if you're new to the channel, welcome. I am a professional data recovery engineer with 20 years experience servicing consumers who mail in hard drives like this one, or anyone from police, courts, heavy industry, you name it, I've seen it all. Now I've removed the PCB to do a quick inspection to see if I can figure out why there's no signal at all on the 12-volt line, and straight away I can see some very obvious electrical damage, and that does look like the 12-volt input side of this PCB. Now I've made videos before on how to repair damage like this. You can check it out in my YouTube channel. And under microscope, you can see that, yes, there's been an obvious power surge that has damaged the PCB of this hard drive. If you look on this side here, it explains why I'm getting no signal on the 12-volt line. These 3 pins are the 12-volt, these 3 are ground, these 3 pins are the 5-volt channel, these 3 pins are ground. These ones are not used. And this power surge has done so much damage that it's actually melted the PCB, which is quite rare. You don't really see that. So a lot of heat's been generated, and this must have puffed some serious smoke out when it was turned on. So the most common cause of damage like this from a power surge is a customer who plugs the wrong charger into their hard drive. And a lot of laptop chargers have the same connection plug as a hard drive, external hard drive like this one. So it's possibly likely that they've plugged a laptop, which is around 20 volts, and this hard drive, which takes 12 volts, and it has done some serious damage. So I'm going to give you a live demonstration by sacrificing a perfectly normal working PCB for this science experiment. This here is a typical hard drive adapter, power adapter, and as you can see, it's 12 volts at about 1 amp, if you can read the fine print there, just down the bottom. 12 volts at 1 amp. Now, here's a common laptop charger. They all are about 12 volts. So this one's 19, so they're plus or minus 18 to 22 volts, generally around 20 volts. And this one's 19 volts at 3.4 amps. That's a huge difference. Now the problem lies with the connectors. The connectors are identical, and what's happening is people are accidentally plugging their laptop charger into their hard drive, and boom, there it goes. So what I'm going to do is a live demonstration, and I'm going to show you exactly what happens when you connect your laptop charger to a hard drive PCB. You can see the experiment did blow this. It wasn't that dramatic, let's be honest. I don't know how the other ones all burnt and completely barbecued. Maybe because they left it on longer. But you can definitely see like there's a patch around here, a heat patch. So it's a very good indication that in this experiment that the PCB has definitely got some damage, and if we test that, it'll be shorted out. So what I'll do is get some spare parts for this PCB. You've got the model number here on the Seagates, 100535537 revision C. Now I've got so many spare parts after 20 years, it's not funny, so I'll just go grab one out of the collection. So it seems like a pretty common PCB, this one. I've got a new one now. But just make note, you can get the same PCB number with different revisions. It may or may not work. For me, it's not worth the risk for data recovery. This is a live job for a customer, so I always like to stick to exactly the correct parts. So here's what it's meant to look like. This is the working one. We can see we've got 2 capacitors here, and we've got this diode here. Now this diode is a transient voltage suppressor, and it's meant to protect this PCB from power surges. Now the capacitors on the damaged one, I mean, it has blown this so hard that the capacitors are actually moved out of shape and balled into one big piece here. So these diodes are meant to put a high resistance on if there's a surge, but unfortunately this surge has been so extreme that it has practically melted it. So what I'm going to do is use some hot air to take these out of circuit, all these faulty components. Try and reball and fix the pinouts of this one. So I'm going to start by removing the 3 components that I need from my donor PCB. Here's the faulty PCB we need to repair. We got to go in here, and this one here is going to be a bit tricky because it looks like it's melted back a bit. We're going to have to top up the solder. First thing is our transient voltage suppressor diode. It's got a direction, so make sure you don't screw that up. Now I've got to solder these tiny little capacitors in, so I'm just going to do it with my soldering iron. Just tack one side, flip it around, and tack the other side. We'll add a bit more solder. And we've got the other capacitor here. Now these don't have a direction, so it doesn't matter which way it goes back in. Okay, I've tacked one side. That looks good. It's held in place. And now I've welded the other side. I've cleaned up the soldering work, and if we just do a final inspection before we screw this PCB back on, soldering looks good here. And I thought this would be a bit harder, but it was actually easy to get in here and put that in. You can see the trace wire is a bit torn off the PCB, so it's still delicate. Let's screw it on, guys, and see if it works. So we've now got this hard drive connected to see if it's going to work. It is detecting with the correct capacity, model number, and serial. So let's run a test to see if the repair has been successful. So the good news is we're getting all good indicators back from this PCB repair. We're getting almost 100 megabytes a second, so it's reading perfectly fine. We've got no errors reported at all. So that's good news. This customer will get all their data back from this damaged PCB. Now, if you need data recovery from a hard drive that stopped working, you can mail in from any location and we will get your data back at the lowest price. I'll see you guys in the next video.